Hello, welcome students to our channel Infinity Scholars Hub. Today in this video we are going to discuss about a topic of class 10th, which is pair of linear equations in two variables. So let's start with this topic. Okay, first of all let's start with the introduction of this chapter. See, we have studied linear equation in two variable in a previous class, right? So let's recall that concept. What was it? What was the general form of linear equation in two variables? Let's see that. So first of all, okay, so see, linear equation in two variables you have seen like this: 2x plus 3y equals to 6, right? You have seen equations of this kind which has two variables and are linear equation. We all know now why it is a linear equation, as the degree of this equation is 1, we say it's a linear equation, and it is containing two variables, that is x and y. Therefore it is called a linear equation in two variables, x and y. Okay, so now let's see the general form of linear equation in two variable. Okay, so a general form of linear equation in two variables is ax plus by plus c equals to 0. Okay, where your a comma b and c are real numbers. Okay, real numbers, and a should not be equal to 0 and b also should not be equal to 0. Okay, so this condition can be even written as, a squared plus b squared should not be equal to 0. Okay, so if a squared plus b squared is equals to 0, then it won't remain a linear equation in two variable. Okay, see, let's consider this simple term for this. Okay, so see, instead of a, if I put 0, consider that a is equals to 0, so this whole term will become 0, right? And the remaining equation will no more remain a linear equation in two variable, right? So for this particular equation to be a linear equation in two variable, your a as well as your b should not be equal to 0. Okay, now talking about the solution of this type of equation. Okay, so the solution of this type of equation was, see, we have seen, okay, solution of a linear equation in two variables is what? See, we can say that x is equals to alpha and y is equals to beta is a solution of ax plus by plus c equals to 0 if a alpha plus b beta plus c equals to 0. The meaning of this is what? We will take an example and we will see what does it actually means. So if my linear equation in two variable is 2x plus 3y equals to 12. Okay, so if instead of x I put 3 and if instead of y I put 2, okay, so this will become what? 2. Now I am considering only the LHS of the above equation, so this is your LHS, okay, and this is your RHS. So if I consider only the LHS, that is what? 2x plus 3y. So on substituting the value of x, that is 2 multiplied by 3 plus 3 multiplied by 2, because in place of y we will be putting 2. So 2 3s is 6 plus 3 2s is 6. So 6 plus 6 is equals to what? It is equals to 12. Okay, so your LHS is equals to 12 and your RHS is also equal to 12. That means your equation is satisfied over here. So on putting the value of x as 3 and the value of y as 2, we are getting the both sides of the equation same. That means x is equals to 3 and y is equals to 2 is the solution of this equation. Okay, now one more thing we should know about linear equation in two variables is, see, we all know that linear equation in one variable has one and only one solution. Okay, that means the solution of linear equation in one variable is unique. Okay, but for such type of equations, that is linear equation in two variable, we have too many solutions for one single equation. Okay, So let's take an example for that also. Let me take this as, okay, again let us consider the same equation, that was 2x plus 3y equals to 12. Okay, let me put the value of x as 2. I will get the corresponding value of y. We have learned in our 9th class how to plot a graph of any linear equation in two variable, right? And we also know that a graph of such type of equation is a straight line. Okay, so I can put any random value of x over here. So let me put x equals to 0. So x equals to 0. If I put x equals to 0, so this will become what? 2 multiplied by 0 plus 3y equals to 12. So 2 into 0 will give you 0. So you will have 3y equals to 12. And your y will be equal to 12 by 3. That means your y is equals to 4. So this is again one more solution, that is x equals to 0 and y equals to 0, y equals to 4. This is one more solution. The previous solution was what? We put x equals to 3 and y is equals to 2. So this was one more solution, right? Likewise, you can have infinite number of solutions. Okay, fine. So let me just erase this. Okay. Now see, let's go on to the next slide then. Okay, now see, general form, it is general form of pair of linear equations in two variables. Okay, now see, they are saying pair of linear equation in two variables. That means you will be having two linear equation in two variables. And note one thing over here, that the variable in both the equations used will be the same. For example, I will write 2x plus 3y equals to 12 and the other equation is x plus 4y is equals to 15. Okay, this is your equation number 1 and this is your equation number 2. So this is an example of pair of linear equation in two variable. Okay, and note the variable used are same for both the equations. Okay, so now coming back to the general form of this type of linear equation, the general form is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Okay, this is the general form of pair of linear equation where your a1, a2, b1, b2, c1 and c2 are real numbers. Okay, they are what? They are real numbers. And a1 square plus b1 square should not be equal to 0 and a2 square plus b2 square should not be equal to 0. So this whole thing we all should know very well, because this is representing the general form of pair of linear equations in two variables. Okay, so now let me give you two equations and we will identify the coefficient of x and y. Okay, so consider this example only. We will take this example. So first of all, let me write them in the general form because they are not in the general form, right? So the above equation or the equation number 1 will be 2x plus 3y minus 12 equals to 0, and the equation number 2 will be x plus 4y minus 15 equals to 0. Okay, now if I ask you what is a1, so a1 is the coefficient of x of the first equation. So this is my first equation, right, and this is my second equation, so it is 2. Okay, then the b1 of my first equation will be 3, then c1 of my first equation will be minus 12. Okay, likewise if I ask you a2, so my a2 will be equal to the coefficient of x of the second equation, so that will be 1 because there is nothing present with x, so that means it is 1x. Then your b2 will be equal to 4, the coefficient of y in second equation, and your c2 will be equal to minus 15. Okay, so this will be the coefficient of x and y in equation 1 and 2 and the constant in equation number 1 and 2. So I hope you all are clear up till here. Okay, now let's move on to the next part. So let's see the next part. Okay, now see, the solution of this type of equation, there are few conditions in this. Okay, there are few cases you can say in this. See, they are pair of linear equation, right? We all know that graph of a linear equation in two variable is a straight line like this. Okay, now I have a pair of linear equation, that means I am having two lines. When I plot both these equations on the graph, I will get two lines. Okay, so say this is some other line. So this is of equation number 1. Let's take that equation as 2x plus 3y minus 12 equals to 0, and this is x plus that won't be horizontal, so let me just okay, so this is like this, and this will be x plus y minus 15 equals to 0. So this line is of equation number 1 and this line is of equation number 2, right? Now there are three possibilities. When you plot the graph of pair of linear equation in two variable, there are three possibilities. The first possibility is that the two lines may intersect. Okay, that the two lines may intersect. The second possibility is that the two lines may not intersect and are parallel to each other. So like this and like this. So the two lines over here are parallel to each other. Note over here that the line which I am saying is actually the line representing an equation, correct? Basically, when we are drawing a graph, what we are doing, we are connecting algebra with geometry, right? What we are doing, we are plotting down the graph of a linear equation in two variable. Okay, so this is say some equation number 1 and this is say some equation number 2. Okay, same thing over here, this is say some equation number 1 and this is say some equation number 2. Okay, and the third and final condition is that both the lines are coincident. That means they are one upon the other. See, this is one line and this is another line which is exactly on it. This is not looking exactly on it, so let me just make it exactly on it. Okay, so yeah, so this is one line representing one equation, equation 1, and this itself is the second line which is representing the equation number 2. So over here you can see that in the third condition the lines are one upon the other. Okay, now simply looking at the equation, you can say whether the two lines are going to be intersecting or the two lines are going to be parallel, or are the two lines are going to be coincident. Based on just the equation you can find out. So for case 1, that is intersecting lines, your a1 upon a2 will not be equal to b1 upon b2, will not be equal to c1 upon c2. Okay, so you just have to see the coefficient of the variables, you have to find out the ratio of them, and you will come to know whether they are intersecting, they are parallel, or they are coincident. Next type of line is parallel. So in this, a1 upon a2 will be equal to b1 upon b2. Okay, but this won't be equal to c1 upon c2. Okay, and for the final condition, you will have a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Okay, these are the three conditions. Okay, and this is how you will identify whether the equation given to you belongs to intersecting lines, parallel lines, or coincident lines. I hope you will have understood everything which we have discussed in this video. I hope you will like this video and you subscribe to Infinity Scholars Hub channel. Thank you.